Last year and the year before, y'all learned how to solve equations. The equations we're going to start solving now are harder. I know you guys like to have procedures and processes in place, so I'm going to go through that same exact poster that we have on the wall in the classroom about how we solve equations. Okay. So the first step for solving equations is we hate fractions. Anytime we see a fraction, we're going to start off by multiplying both sides by the common denominator. If there's only one denominator, that's the common denominator. All right, so that's the first step. The next step is we're going to distribute. Now I made this kind of expanded distribution here because I think a lot of times you guys forget what you're doing is you're multiplying. You're going to multiply by everything, and the most common mistake you guys make is you forget the second one. So if you find yourself making that mistake, or if this is not something you're good at, I'm going to encourage you to write it like this. 3 times x, just write that out, plus 3 times negative 5. And when you work that out, you have 3x minus 15. That's going to help. If you find yourself forgetting this, do this in 2 steps so that you have that step right there. That's going to help you out. Okay, so first step is we hate fractions. Second step is to distribute. The third step is to combine like terms if there are any. Okay, so I had this long, complicated thing here. What I did was I found each one on its own, so I gave each one its own symbol that I put around it. So for example, the x's, I put a circle around them, and if you want to use markers, you know I got markers all over the place. I have 3x minus 2x plus 1x. 3 minus 2 plus 1 is, that doesn't sound right. Yeah, that's right, 2x. Okay, great, 2x. Now I'm going to look at the numbers. Now, we can put them in whatever, we'll talk about the order we put them in a lot later on, because we have this y here. But I have 4 plus 3 minus 2. 4 plus 3 is 7. 7 minus 2 is 5. And the last term I've got here is y. I've got y. Now notice on this just said plus y and this said plus x. Whenever I see a number that doesn't have a coefficient, I put that invisible 1 in front of it so that I don't forget that there's something there. So I have 1y and 2y. That gives me 3y's. You don't have to do this unless you're messing this up. Okay, so first we hate fractions, so we multiply by the common denominator. Second, we distribute, carefully making sure we distribute to every term. Third, we combine like terms, carefully making sure that we don't have any chicken mango action going on here. The next step is that we're going to get x's on one side and numbers on the other. So what that means is we're going to use opposite operations. So if I have like a 3 or like a 3 that I'm trying to move to the other side, I'm going to subtract 3 from both sides. If I have a negative 5x that I'm trying to move, I'm going to add 5x to both sides. So we're going to use opposite operations. And then the last step is I want to find 1x. So I'm going to divide to find 1x. All right, so these are our basic steps, and I've attached this to the classroom so you can see what they are. These are our basic steps. So now we're going to actually practice some of these. And I'm going to be straight with you. These are harder equations, harder than the ones you've probably done in the past. So we're going to start right now with just solving. We're not going to do all of these. I'm probably going to do like maybe 3 of them. I'll probably do 2 of the word problems and, well, 3 of the problems, and then I'll save the others for in class if we need them. Okay, so let's look at this first one here. This first one right here has fractions. And what do we know about fractions? We hate fractions. So we're going to multiply both sides by the common denominator. When I say both sides, I mean both sides of the equal sign is what I'm going to multiply by the common denominator. Well, I see a 2 and a 4. That means the common denominator is 4. But if you look at that and you're like, I don't know how I'm supposed to figure that out, multiply 2 times 4, your common denominator can be 8. I didn't say the least common denominator, I just said a common denominator. All right, I'm going to multiply by 4. So what that means is I'm going to multiply every single term by 4. Okay, so that means I have 4 times 1/2 m plus 4 times 7 plus 4 times negative 1/4 m equals 4 times negative 5. Okay, if I want to see what that looks like, of course I don't have my calculator over here. Let me pause. Back with my calculator, and wouldn't you know it, as soon as I got up to go get my calculator, guess what I found looking right next to me? My calculator. So it's the law. All right, so I'm going to start by doing 4 times 1/2. In our calculators, we do alpha y equals. We put a 1 on the top and a 2 on the bottom, and that gives me 2. So that means this is 2m. 4 times 7 is 28. 4 times negative 1/4. 4 times, whoopsie, negative 1/4 is negative 1. And I get negative 1m. And that equals 4 times negative 5, which is negative 20. So I've distributed now. So I've finished my second step, which is to distribute, being careful to make sure I distribute to every term. My next step is to combine like terms. So I'm going to look for terms that are the same, and I'm going to circle them. I see 2m and negative 1m. Well, 2m and negative 1m makes 1m plus 28 equals negative 20. Now, some of you are going to want to try to combine these two, but remember, this is a wall. I can't combine across the equal sign. So at this point, I've combined everything. So when we say combine like terms, we mean everything on one side of the equal sign. We don't combine across the equal sign. All right? So now the next step is to get my x's on one side and my numbers on the other. So I'm going to use opposite operations. Well, I have all my x's, and when I say x's, I mean variables on the left side, but I've got this 28 here. I want to get rid of it, so I'm going to subtract 28. And I have 1m equals negative 48. So I think the equation is I think the answer is negative 48. And I'm going to check myself. How do I do that? I plug it back. There's two ways to do it. The first way I can do it is I can plug 48 in everywhere I see an m and see if I get a true statement. So let me show you what that would look like. I could say 1/2 of negative 48 plus 7 minus 1/4 of negative 48 should equal negative 5. So let's put all that crazy, well, wrong calculator. Let's put all that craziness in the calculator. 1/2 of negative 48. And again, I put it in exactly like I wrote it. Plus 7 minus another fraction, 1/4 of negative 48 equals negative 5. That is a true statement. Now, the reason why we make sure it's a true statement is because there may be like 5 plus x squared or something over here. So I have to make sure that this stays true. 5 equals 5 is a true statement, so this is, I have confirmed that my answer is right. There's another way I can confirm this using the calculator. And the way I do that is, I take the left side of whatever's in the equal sign, I put it in y1. So I would put alpha y equals, I would put 1/2, I don't know why I couldn't find the 2, 1/2 x plus 7 minus 1/4 x. Nope, see, okay, I don't know what just happened, it just went crazy. And then you get rid of that. Remember, when you're in the denominator, you have to arrow right to get out from under there, x. And the next one I'm going to put is negative 5. So I put what's on the left side here goes in y1, and the right side goes in y2. And then I hit second table. Remember, we go into the table. And what I'm looking for is, I think the answer is negative 48. So I'm going to make my x value negative 48 and see if y1 and y2 are equal. Now, I don't know about you, but I don't want to scroll for 5 hours to get to negative 48. So remember yesterday I showed you in class, if you hit second window, you can set your table start to negative 48. When I look at the table, when x is negative 48, y1 and y2 are equal, notice they're the same values I got when I verified. So I can also prove that by showing that in my table, x, y1, and y2, I had negative 48 for x. When x equaled negative 48, I had negative 5 for y1 and negative 5 for y2. Now, some of you are going to say, well, why can't I just solve it like that? Because, remember, we're learning a process that we're going to be able to use for any problem they give us. Okay? So let's try another one. This is going to be a long video because it's a lot of examples. But remember, we have to be super strong at solving equations. And we only have 2 days to do it, so we might have to watch a little more than we want to. Okay? So when I look at this, I don't see any fractions, which is great because we hate fractions. I don't see any parentheses, which means I don't have to carefully distribute. So I'm already down 2 steps in my 5 steps for solving an equation. Now all I need to do is start combining like terms. When I look on this side of the equal sign, I see I have one W and one number. So I'm good to go. But over on this side, I have 2 W's. So I'm going to have to combine those together. So I have negative 3.5W, well, over here. I call everything that I didn't do anything to, I call those leftovers. So I'm going to bring my leftovers straight down. Negative 4.5W minus 6 equals negative 3.5 plus 5. Look, I don't know what that is. I'm not trying to mess this up. So negative 3.5 plus 5, that's 1.5. So I have 1.5W plus 2 plus 10 is positive 12. Okay. Now I see I've got a W and a number, a W and a number. So I've finished this step. I've got my terms combined on both sides of the equal sign. Now I'm going to start adding and subtracting to move things. Now I'm going to be honest with you. When I was a kid, they taught me to get your X's on the left side and your numbers on the right. I don't really care which side you get them on. When I do examples, I'm going to move my X's to the left and my numbers to the right. I will tell you, I would encourage you to do it this way because when we do inequalities tomorrow, it's going to make it easier to interpret them. But it's not wrong if you do it the other way. It's just going to kind of make interpreting your inequalities a little trickier. So I want to only have numbers on this side, but I've got this 1.5W. So since it's positive, I'm going to subtract 1.5 W's. Now I've got 6 W's minus 6 equals 12. Well, now I've got this minus 6 I got to get rid of, so I'm going to add 6. Again, I'm trying to move this stuff around. I got 6W equals 18. My last step is to find 1x by dividing. So I'm going to divide both sides by 6. I get W equals 3. So I think W equals 3. Let's confirm whether or not I'm right. So the first way I can do it is by substituting. And I'm going to always use the original equation. I could use this, but I don't want to because I want to make sure that I use the equation that they gave me before I started messing with anything. Okay? So negative 4.5 times 3 minus 6 should equal negative 3.5 times 3 plus 2 plus 5 times 3 plus 10. Holy smokes, that's a lot. Okay, so negative 4.5 times 3 minus 6 is negative 19.5. Okay, so let's try the other side. Negative 3.5 times 3 plus 2 plus 5 times 3 plus 10 is not the same thing. Hold on, let me see if I messed this up. I got 16.5 here. So what did I do wrong? That was negative 6W. This should be negative 3. Okay? So look, So I could just stop this and erase it and redo it. But what did doing this tell me? It told me I did something wrong. And I was able to, because I didn't get the same thing, I went back and looked at my equation and I said, wait a minute. Something is wrong here. I've done something wrong. And I realized that this should have been negative 6W, which means this should have been negative 3. So let's try it again, this time with negatives. Okay, look, everything is a teachable moment. I'm going to insert a negative here. Now, I got 7.5 when I use negative 3. Hopefully this works right. And then I'm going to try this one. I'm going to put negative 3's. And I get 7.5. This is why we check our work. Because it didn't take me long to do this, and it would have been even faster if I had put it in here, which I could also do. This is why we check our work, because of what just happened to me. I wouldn't have realized. I might have been like, yay, W equals 3, we're good to go. But because I checked my work, I knew that I had done something wrong, and it allowed me to correct that mistake before it became permanent. All right? I feel like we should do... Well, we kind of did some distribution, so let's just look at this last one. Actually, that's good. Let's do these two. We'll do some more in class together, and make sure that you come with questions about whatever processes I did.